शंकराचार्य महाविद्यालय, शंकराचार्य महाविद्यालय। इस पर कर्मभूमियः तपोभूमियः जीवन का आधार है, शिक्षा का सरताज है। शंकराचार्य महाविद्यालय, शंकराचार्य महाविद्यालय। शंकराचार्य महाविद्यालय, शंकराचार्य महाविद्यालय। आधार है, शिक्षा का सरताज है। श्री शंकराचार्य महाविद्यालय, श्री शंकराचार्य महाविद्यालय। भावी पीढ़ी को गढ़ने वाला उत्तम शिक्षा इसकी शान। चरित्र यहाँ पर निर्मित होते, सदाचार इसकी पहचान। कर्मठता और सेवा भाव, कर्मठता और सेवा भाव इसका अलग अंदाज है। कर्मभूमियः तपोभूमियः आधार है, शिक्षा का सरताज है। श्री शंकराचार्य महाविद्यालय, श्री शंकराचार्य महाविद्यालय। अलग जाति है, अलग धर्म है, अलग हमारी बोली बानी। अलग जाति है, अलग धर्म है, अलग हमारी बोली बानी। अलग धर्म है, अलग क्षेत्र है, पर मकसद की एक कहानी। वैचारिक मतभेद भी मिलते, वैचारिक मतभेद भी मिलते, लेकिन एक आवाज है। कर्मभूमियः तपोभूमियः आधार है, शिक्षा का सरताज है। आगे बढ़ना, बढ़ते रहना, मुश्किलों से लड़ते रहना। आगे बढ़ना, बढ़ते रहना, मुश्किलों से लड़ते रहना। पैर न खींचना, हाथ बढ़ाना, कमजोरों को सदा उठाना। मानवता की सेवा करना, मानवता की सेवा करना, ऐसा यहाँ रिवाज है। भूमिया तो भूमिया का आधार है, शिक्षा का सरताज है। श्री शंकराचार्य महाविद्यालय, श्री शंकराचार्य महाविद्यालय, श्री शंकराचार्य महाविद्यालय, शंकराचार्य महाविद्यालय। इस पर हमको नाज है, भूमिया जीवन का आधार है, शिक्षा का सरताज है। शंकराचार्य महाविद्यालय, श्री शंकराचार्य महाविद्यालय।
Good morning, ladies and gentlemen, to this magnificent, glorious day. I am Rishabh Singh, BCA final year student from Sri Shankaracharya Mahavidyalaya. It gives me immense pleasure to welcome you all to this certificate training program on artificial intelligence conducted by Department of Computer Science, Sri Shankaracharya Mahavidyalaya, Junwani, Bhilai. I cordially invite Thakur Devraj Singh sir, Head of Department Computer Science, Sri Shankaracharya Mahavidyalaya.
Thank you, Rishabh. Good morning to all. As we know that our department is organizing 21-day certificate training program. Today is 15th day of our program. Previous day we have learned so many topics of artificial intelligence. In this training program, the theme is based upon artificial intelligence to help the student understand the result of artificial in human life. It will focus on major issues, solution, and long-term effect associated with artificial intelligence. With all those words, I extremely delighted to pronounce the key speaker for the day, Dr. M. Srinivas Rao, sir, professor from Dadi Institute of Engineering and Technology, Visakhapatnam, Andhra Pradesh. I hope that today's lecture will be productive and fruitful for your future. So thank you very much, sir.
I humbly invite J. Durga Prasad Rao sir, Additional Director of Sri Shankaracharya Mahavidyalaya.
Hello, am I audible?
Yes, sir.
Yes, sir, you are audible. Sir, I humbly invite J. Durga Prasad Rao sir, Additional Director of Sri Shankaracharya Mahavidyalaya.
Fine, thank you, Rishabh. The chief key person has joined. The key speaker of this session has joined.
Yes, sir. Yes, sir. Join, sir. Srinivas, sir. Rao, sir.
Yes, sir.
Okay.
I have joined.
Okay. Very good afternoon to one and all. I humbly invite Srinivas Rao ji from Anakapelli on this occasion of certificate training program conducted by Department of Computer Science, Sri Shankaracharya Mahavidyalaya. My congratulations to all the team, which is captained by Thakur Devraj Singh and faculty members, Kavita Madam, Poonam Yadav Madam, Jasleen Madam, and dear students, both from PG and UG. As far as this whole event is concerned, every day you are getting new knowledge, new insights, new ideas, new explanations of a particular aspects. Many times one may feel key certain topics are repeated, but those topics are repeated because those are important topic on one hand, and secondly, every expert, every teacher, every entrepreneur has different idea of saying a thing. For example, it has already been said, and even you might have observed that how many times you read Ramayana, it will give you a different flavor. It will give you a different understanding. And let me tell you very frankly, very clearly, just in 20 days workshop, 21 days workshop, you are not going to become expert of artificial learning. It is a vast and very vast course. And it's an ocean where you have to make sure in which particular aspects you are going to focus, and then you have to expertise on this, and based on that expertise you generate new ideas, you discuss new ideas, and then with these ideas you enhance yourself with capabilities and skills, and then you can grab the job from the company which works on those ideas of AI. Means it's an immense field. On one hand, it has applications on e-learning, ICT. On other hand, it has applications related to financial corp. On third hand, it has applications related to consumer products. And then again, it has wide aspects in cryptocurrencies. Means artificial intelligence is everywhere. Now it is for you to focus on where you want to give your best. So in the same note, we have a very great speaker, Srinivas Rao Moli from Dadi Institute of Technology, and he is again from Andhra. He has done his PhD. I was reading his resume. It was sometime in 2018, and he has done his main education or technical educations from Hyderabad. And I welcome you, sir, on this platform of Sri Shankaracharya Mahavidyalaya. And I am Dr. J. Durga Prasad Rao, and one of your faculties in Dadi Institute of Technology, A. Venkateshwar Rao, is a very good friend of mine. He has also been associated with Sri Shankaracharya Mahavidyalaya till 2005, and then he shifted his base from Chhattisgarh to Andhra Pradesh. And he is a very nice person, and we really wanted that he should also be one of the key persons, but due to his some technical considerations and due to his busy schedule, that he told he was also academic coordinator in NAC. So it is being difficult, though we are still praising him to be part of our platform. And soon we will be having him this field also, and we are very thankful to him also through you. Please convey our regards to him, because he has been very influential in making in getting us some good communicators, some good philanthropists from good experts of people like you, so that our students or our participants could benefit with maximum ease. Thank you. Thank you, Srinivas Rao Garu. It was really a great moment to find you here, and we hope that this interaction will be a good one for our students and our learners. Thank you, sir. Thank you very much.
We feel honored to have with us Honorable Chief Guest Dr. M. Srinivas Rao, Professor at Department of Computer Science and Engineering, Dadi Institute of Engineering and Technology. Sir is a PhD holder. Srinivas Rao sir is a PhD holder, and he has a vast knowledge of mobile computing, cloud computing, machine learning, artificial neural network, and so on. So I would request Srinivas Rao sir to start their session.
Thank you, Rishabh Singh, and thanks to Durga Prasad, Dr. Durga Prasad Rao sir, and the team of Shankaracharya Mahavidyalaya. And it's an immense pleasure to be invited as guest lecturer for this artificial intelligence training program in Shankaracharya Mahavidyalaya. First of all, I would like to congratulate Shankaracharya Mahavidyalaya team for conducting this artificial intelligence training program for 21 days. It is not an easy thing for conducting 21 days. I can imagine the hard work behind this training program by the team and how much pain they have taken. So I can imagine, because we also conducted these sessions. So congratulations to all the team members of this training program. And at the same time, congratulations to participants of this training program. And thanks to the team for inviting me as a guest lecturer for this program. So this is one important thing, one important day in my life also. And so we'll start the program. And just wait, I'll share my PPT. So very good afternoon to one and all. Good afternoon. And here in today's program, so we will discuss about the machine learning and so Python for data science. Actually, you have been listening so many lectures since February 1st. Here, artificial intelligence by the many resource persons. And artificial intelligence means a simple thing is machines mimics the humans, or we are giving artificial intelligence to the machines by training them. So artificial intelligence is a concept. Artificial intelligence is a technique. Okay. So by using that concept, by using the techniques, we can train the machines. Okay, right? To train that one, we need the machine learning algorithms. Okay, so machine learning algorithms are practical and artificial intelligence is a concept. So to implement the artificial intelligence concepts, we need to use the machine learning algorithms. Actually, machine learning is a subset of artificial intelligence. Okay. And in today's class, we will discuss about in today's session, we will discuss about the introduction to machine learning and types of machine learning algorithms like supervised machine learning algorithms, unsupervised machine learning algorithms, and finally, so Python programming for data science. Okay. And so what do you mean by machine learning? How you can define the machine learning in the sense, the definition of machine learning is, see, is my screen is visible to all of you?
Yes, sir.
Okay. So machine learning is about the construction and study of systems that can learn from data. So actually this is one of the definition. So there are many definitions are there. One of the definition is machine learning is about the construction and study of systems. Means you can so train the machines. You can train the machines. The machines can work like a human without intervention of the humans, right? So how you can train the machines? How you can train the machines? So before that, we will discuss what is traditional computing and what is machine learning. So what is the difference between these two? So all of you familiar with the traditional computing? How the traditional computing? In traditional computing, and the programmer writes a program. Programmer writes a program for a particular to accomplish a particular task. So the computer takes the program as input. Okay, or the program takes some input or observations given by the programmer. So by taking that input, by executing the program, it gives an output. Okay, it gives an output. So you all know, so you are executing C programming, you are executing Java programming, you are executing some other Python programming. So like that, different programming languages. How you are executing? By writing a programming, you are giving the input. By executing the program, a program can take that input and it can give the output. So this is the traditional computing. And coming to the machine learning, you are not writing any program. You are not writing any program. Simply, you are giving both input and output to the computer. Means, what is that output? Means in machine learning, you are making models to accomplish a particular task. That model can give you output. So without intervention of the humans. In machine learning, computer takes input and output as data. Means you are training the computer with input and output as data. And after training that with the help of that data set, computer can write its own program. So that computer can write its own program to accomplish particular task. So this is the difference between the traditional computing and the main computing, machine computing. Okay. Okay. So how that machine is learning? So in what way it is learning means? So there are so many algorithms are there. Machine learning algorithms. Okay. Just a minute. Okay. So how you make learning the systems means you are giving a training to the system. How you are giving training? By providing some training data set. Okay, and based on the training data set, the computer selects one of the machine learning algorithm which is suitable for the particular task. So you the computer cannot select a single algorithm for different types of problems. It can select the algorithms based on the problem or based on the task. Okay. So by taking the input of the training data, it can choose the best learning algorithm to accomplish the task, and it gives the output. Means it predicts the output. So training data set contains input and output. Sometimes it is only giving input, and based on that only it learns. So what is the it can understand the problem. Okay, problem of the as a problem statement, and based on the problem statement it can choose one of the best algorithm. So one of the best algorithm. Okay, here in machine learning, the first thing is, so for a different task, so different data sets will be available. So you need to take some standard data sets. You cannot take the data set so wherever the data set is available, you cannot take. So you can take, you need to take the data set, a standard data set. The standard data sets are available from some standard websites like Kaggle, Kaggle, Kaggle. So, okay, before that, so you have the training data set. That training data set can contain different features, or it may be one dependent variable, one independent variable, one dependent variable, or many independent variables and one dependent variables. Like that, so different features it can have. You are providing the data set to the computer, and computer chooses a best learning algorithm, and based on that learning algorithm, it takes the data set as the input, and it prepares itself as a model for giving solutions for that particular task. Whenever the model is completely developed, that model can take a new input which is not in the training data set. So it can take a new input. So you can give a new input, so it will give the output for that one. So the input may be testing data, or input may be whatever the input for testing. Or, you can take entire data, you can divide into 70% as training data and 30% as testing data. Got my point? What are the data set you have taken from the Kaggle website regarding a particular, suppose if you want to find whether that rain will happen today or not. So for that one, so there is a huge number of records data will be available in the Kaggle website. So you can download that data from that website, and the data may contain maybe thousands of records or maybe 1 lakh records. So what are the number of records? And you can divide that entire data into 70% and 30%. Okay, 70% data is for training data and 30% data is for testing data. Okay, so that 70% data you can give as input to the system, and after developing the model, so you can use that 30% data as a testing data. You can use that testing data as input and you can get the output. So this is the procedure, basic architecture of machine learning. Okay, and so there are different types of machine learning algorithms. One is supervised learning, and another one is unsupervised learning, and the third one is reinforcement learning. So there are different types of machine learning algorithms. And what is supervised learning and what is unsupervised learning? Means supervised learning means, so you are supplying data or you are feeding data to the system with a labeled one. Suppose the data may contains 2 columns. So one is X and another one is Y. You can call X as dependent variable and Y as independent variable. So Y is our output and X is input. So for a particular input, so you will get the particular output. So this is the data set contains. Okay. In supervised learning, whatever the data set you are feeding to the machine, that data should contain the labels of that features. Okay. So what are the labels of the features in this data set? For dependent variable is the label is X, and for the for the independent variable variable label is X, and for the dependent variable, so the label is Y. Means to calculate the Y is depends on X. Suppose Y equal to mx plus c equation is there. If you want to calculate the Y, you need to take the value of X. So X is independent and Y is dependent. So in this way, this data, label data, means you know the input and you know the output. So that entire data set you are providing to the machine. So that is called supervised learning. In supervised learning, there are 2 concepts. Many concepts are there. Generally, classification concept and other one is the regression concept. Okay. In classification means you can classify the given data set. Maybe here the probability of whether it is yes or it is no, whether it is human or it is an animal. So like that. So you can classify the value. Hello. So okay, you can classify the data. And coming to the regression, so here regression means the quantity. So you are predicting a quantity. So classification, you are predicting a probability. In regression, you are predicting a quantity. It is a discrete value. So regression is a discrete value. And coming to that unsupervised learning. So there are, okay, unsupervised learning means in similar way, whatever. Okay, again we will discuss supervised learning in detail. So before that, so unsupervised learning means what are the data we are supplying to the machine, so that is unlabeled. Then how it separates the data means, so it identifies the internal structure of the data. It identifies the structure of the data. So based on the structure, so it can groups into the data, groups into different groups. Means the unsupervised learning are clustering type and dimensionality reduction. Okay, before that, supervised learning means the training data set is a labeled data set. As I said, the data set may contain two features. First feature is X and second feature is Y. So first feature is input and second feature is output. Okay. So to calculate that output or to predict the output, you need the input. So here X value is the input and Y value is the targeted value. So whatever the target, so you required, so that is the Y value. And so by supplying this training data, that machine generates a model. So by choosing a best learning algorithm. So in machine learning algorithm, so many learning algorithms are there. So among all the algorithms, it chooses the best algorithm. And new data set consisting of only the input and value is feed. That means after model the system, you are giving a new input, which is not present in the training data set. For the new input, it predicts the output. So after fully developed model, you can give only input. Finally, it can give the output. Okay. So like this one. So in supervised learning, first thing is you are supplying the data. So data contains two features. One is X, other one is Y. X is input and Y is your targeted output. Okay. So that data you are supplying to a learning algorithm. So that learning algorithm trained with this data, and after that it can develop a model. After completely fully developed model, you can give any input which is not in the training data set. You can give any input. So by taking that input and finally it gives your output. Means it predicts the output. Okay. So your main thing is the data set is contained a labeled data, means directly feeding. Like suppose a teacher teaches a student. How the teacher teaches a student? So every information is supplying to the student. Teacher supplies giving every information to the student. Okay. Means teacher is guiding the student. So that is like supervised learning. Okay. And in that two types of supervised learning, classification and regression. Okay. Here classification. So classification has a discrete values like yes or no, or 0 or 1. Okay. Regression means it is a continuous value. Classification means suppose if you supply an image as input to the model. Okay. And that model, suppose that image may be human or it may be an animal. So that classification model predicts the image either human or animal. Means classifying, it is a discrete value, 0 or 1, yes or no. So like that one. But coming to the regression, suppose you are supplying a data like you want to predict the health of a person. So you are supplying the data like age of the person and weight of the person and that BP value or sugar value, like that. So whatever that values are, you are giving input. And finally, so you are predicting whether that person is healthy or not. So here we are saying that in regression, there is a continuous value. Or suppose you are giving the age of a person and you are giving the height of the person. You are predicting the weight. In that weight, you can predict some 30.5 or 60.5 or some 70.8, like that. That is a continuous values. Okay. Quantity, you are predicting a quantity in a regression. In classification, you are separating like different classes. So there are two different concepts in supervised learning. So like this, classification, there are two diagrams regarding classification and regression. Okay. In classification, predict class of the object. Here, if you observe the diagram, so it contains so that blue color balls and some pluses. So like that, two different classes. We are separating these two classes. Okay. So how many number of classes? So that is the number of classes limited and predefined. In coming to the regression, so numerical value, you are predicting the price of an item or a weight of a person or number in a group. So like that. So you are predicting a continuous value. You are predicting a quantity in regression. Okay. For supervised learning means in classification problem, suppose there are three different flowers. So the name of flowers are Iris setosa, one is, and other one is Iris virginica, and other one is Iris versicolor. So like the different flowers are there. How can you classify? Suppose you have given some 10 flower information, then how can you predict whether this is the first one, this is the second one, this is the third one? How can you classify? Yes, see that once observe the data. Sepal length is the first feature, second one is the sepal width, third one is the petal length, and fourth one is the petal width. So based on these four features, so we can predict what type of species is that one. Okay, either first one, second one, or third one. So this is the data we have. So we have taken the past data, available data. Okay, based on this data, you can train the machine by supplying this data, and that machine can select a best classification algorithm. And by training with this data set, so it can prepare it as a perfect model. It can make it as it can develop it as a perfect model. After developing a model, you can give any value of this sepal length, this sepal width, and this petal length, and this petal width. So any value. So not in this data set. So any new value. So definitely it can predict the species. Okay. In this data set, first four columns are the input values, and the last one is the target value. Okay. So this entire data set is labeled one. So all features are labeled. So supervised learning instance, we are supplying a label data. By taking this label data, by training with this label data, so the system can develop as a model for classification problem, and finally you can give any value, so which is not included in this data set. So it will predict the species. Okay. So like this one. So how that internally supervised learning works means, so here this is the system, and here so you can upload this label data to the computer for training. So this is the training data set. First four columns are the input, and last column is the target one. Means you are guiding the computer. Suppose so the sepal length 5.1, and sepal length width is 3.5, and petal length is 1.4, and petal width is 0.2. So by giving this input value, the system should identify the species as setosa. So like that, you can give any number of numerous records. You can supply numerous records to this machine to model the classification, to accomplish the classification problem. Okay. Here you are supplying this entire data to the system, and after that, that system build a model based on that training data set. Okay. It can create a function. So this is a mathematical function. Actually, that machine learning is based on so many mathematical equations and mathematical concepts, but no worry. So they all are basic ones, and after training with this data set, it can develop a function, and it can take a new input data. For that new input data, it will predict a new input data 1, 2, 3, 4. So the first four columns, we are not giving the output. Okay. After developed a model, so we providing only the input. So first four columns are the input values. We are not providing the output value. And by taking these input values, it can finally predict the output. So this is a classification. Means how it is classified? Based on the training data set. Based on what features it classified, the flowers sepal length is one feature, and sepal width is another feature, and petal length is one feature, and petal width is another. So like that, 4 features. Okay. So this is a classification. And like that, suppose you want to give an image as input to the model. Okay. So this one is the input, and it will predict an output like it is a sneaker. And next, one more image. So it is predict it is an ankle boot, like that. So in target values, many values are there. Which value? So this image, what are the input you have supplied, that comes under which class, that will be predicted by this classification model after training. Okay. So like that. So you can give a t-shirt as an input, and it will predict it as a t-shirt. And so one more image, it can predict as it's a bag. So like that. In supervised learning, so applications of supervised learning are spam detection, spam filtering, face recognition, image recognition. So like that. So many applications are there. Spam detection in the sense, as you all know that familiar mail, Gmail is there. Na? So it internally having this classification, spam detection. Based on some input data within that mail, it can specify that this mail is a spam, this mail is a non-spam. If it identifies the mail is spam, that spam mail will put into the spam folder. So like that. Face recognition, whenever if you want to recognize a face by supplying an image, so definitely it can recognize. And image recognition in the sense, suppose you as I told already, if supply an image, it can classify that image is human or image is animal. So like that, image recognitions. So coming to the regression problem. In regression problem, the output is quantity based. Output is quantity based. So like it is a continuous value, means suppose in this input footage and output is actual price. So the area of a particular room or particular house, how much cost it's? So 2.1 2.4 lakhs, or like that, some data. Okay. So in a quantity, so you are predicting a price, or you are predicting a weight, or you are predicting something which is a continuous value. Okay. Scoring for lending loans. If you want to take a loan, so you should have some credit limit of credit scoring. Like some other application is drug responses, how the drug is response to the treatment, like that. Stock price predictions, everything. Stock price prediction means, suppose our stock price for a particular item is 100 rupees in previous day, yesterday, and today if you can predict that may be some 120 rupees, and from tomorrow it may be 80 rupees or 80.5, like that. So you can predict the stock prices. And that algorithms you can use like k nearest neighbors, decision trees, naive Bayes algorithm, logistic regression algorithm, support vector machine algorithm, like that. Different algorithms are there. Okay. So coming to the unsupervised learning, the trained data set which doesn't contain any label data. Okay. So training data set may contain only the input value, and it may not contain the target. It may contain the target value, but it may not contain the label for the target value. So what are the data? So suppose you are giving the same data, X and Y. X is an input and Y is output, that you know. But when you are supplying the data to the system, if you may not know the system may not know the X is an input and Y is the output, but it takes the both the values, and it can identify the internal structure. It can identify the internal structure of the data, and based on that internal structure, it can cluster. It can group the data. Okay. So like that. So learning algorithm, we are supplying the data with X only. We are not supplying the Y. Okay. That data is separated into cluster 1, cluster 2, cluster 3. The clusters, each and every cluster having some data set. That data set having the similar properties, similar behaviors, like that. Such type of data you can separate as the clusters. Okay, here the whatever the data you have supplied, that entire data is divided into 3 clusters: cluster 1, cluster 2, and cluster 3. Okay. So here no label for target, and it doesn't have any feedback, and so a hidden data structure in data. So that learning algorithm can identify the whatever the internal structure of the data, and based on that internal structure, based on the properties of that data, it can divide into clusters. In this unsupervised learning, so there are 2 types. Like in supervised learning, classification, one is classification, another one is the regression. Like in unsupervised learning also, clustering and dimensionality reduction. There are 2 different concepts. Clustering means group of the data which can have the similar properties. Okay. Dimensionality reduction in the sense, suppose when you are giving a data which can have the more than 2-dimensional or multi-dimensional, it is difficult for the system to solve that or to find the internal structure of the data set. At that time, you can reduce the dimension. Suppose you have given the 4-dimensional data, so the system may reduce the 4-dimensional to 3-dimensional, 3-dimensional to 2-dimensional. So if it is 2-dimensional, it is easy. So if it is more than 2-dimensional, it is a complex data. So it is difficult for system, or takes more time for that to solve that problem. So dimensionality reduction is a concept of unsupervised learning. Okay, in clustering, so you can give different inputs. Here, see that in input, some input as stars, and some are ellipses, and some are like different symbols. So there are here 3 or 4 types of symbols we have combined, and that entire data we are supplying to the model, and that model, it separates the similar symbols as clusters. See here, 3 different types of symbols we have mixed data, and that mixed data we supplied, we feed to the model, and after training that model with this data, it can develop a model, and it can cluster the entire data. So first thing, see here, this one is the one group, and this is another group, this one is another group. Similar symbols are separated, or similar symbols are clustered. Okay. So unsupervised learning methods can analyze complex data that humans might find difficult to interpret. Okay, here actually here there are 4 different symbols, so 4 different clusters. Dimensionality reduction. Suppose, see, this one is the 3D. So 3D length, breadth, and width. Suppose like that 3 dimension, and how this 3 dimensions are separated as reduced into the dimensionality reduction. So top layer, it separates the top layer, and it separates that vertical lines like that. So simply it can reduce that 3-dimensional to the 2-dimensional, and 2-dimensional to the 1-dimensional. So it is easy for solving such type of problems. In supervised, so what is the difference between the supervised learning and unsupervised learning? Means in supervised learning, we are feeding the data with labels. In unsupervised learning, we are feeding the data without labels. Okay. So in lesser amount of data and clearly labeled data for training, and opt for supervised learning. Okay. So for better performance and results for larger data, so you can use the unsupervised learning. So one more thing here, that difference between the supervised and unsupervised. So you are giving the data like animals. So X is the input. The X may be a cat, X may be a dog, or X may be bearer, like whatever the image you are giving this image, and system predicts. Suppose if you are giving this image, first image, system predicts it is a cat. Okay, means, but you are providing the data, both the images as well as the target value. But coming to the unsupervised learning, we are supplying only images. We are supplying only images. We are not supplying the target value. So based on these images, that model can separate these images into clusters, like groups into cats are groups into one, and dogs are groups into one, bears are groups into one category, like this one. Okay. So cats clustering, dogs clustering, and bears clustering. So like that. So this is unsupervised learning. And the advantages of machine learning. So it is very fast, accurate. So it is very fast, accurate, and efficient. Means compared with the human, so within no time, so it can give the output. Disadvantage: difficult to identify and rectify the errors. Okay. So what if the suppose error occurred in that model? It is very difficult for human. So where the error has occurred. Okay. Some applications of machine learning. So what type of applications we can use this machine learning means email spam detection, and second one is face detection and matching. Means suppose if you want to unlock your mobile, so then you can use that for face unlock. Okay. And sports predictions, ATMs, credit card fraud, stock predictions, smart assistants like Amazon, and product recommendations, self-driving cars, language translations, means Google translation from one language to another language you can translate by using this machine learning. And sentiment analysis, means in the social media you can post that sentiments like happy, sad, so angry, like that. So you can analyze that sentiments. So and medical diagnosis, like you can diagnose that diseases in medical field, like that. So many applications are there. So best programming languages to develop that machine learning models, you can use the Python, or you can use Java, you can use C, or you can use C++, or R programming, any JavaScript. So like that. Okay. So many programming languages are there. And Python for data science, in the sense, so many Python concepts are there for data analysis. Okay, the libraries like NumPy, SciPy, Pandas, Matplotlib, Seaborn, sklearn. So like that, many packages are available in that Python. If you want to execute any Python program, so you can install your Anaconda Navigator. So by default, you can get all these packages in Anaconda Navigator. So you can get that editor like suppose the editor Anaconda Navigator, editor like Jupyter Notebook, or otherwise, so one more editor like Spider. So these two are the IDEs to execute the Python programming. Okay. You can load the Python libraries by importing. So by using the import keys, NumPy as NP, like that. So many packages, NumPy, SciPy, Pandas, Matplotlib, Seaborn, whatever the packages you need, so that you can import. So means defaultly you can get this Anaconda. So suppose this is the Spider. Okay. Here you can write your program. So in Python programming, whatever that task, you can develop a program. You can write the program here. Simply you can execute by clicking this. I think all of you are familiar with this Spider and Jupyter Notebook. So these two are, so you can use for executing for executing machine learning algorithms. Okay. For data manipulation, you can use the NumPy. For the time being, I can't go into depth to this Python programming. So I'll give brief introduction to these packages. For data manipulation, you can use the NumPy for scientific computations, and for if you need that arrays, so then you can use this NumPy. And for NumPy, you can use these coding lines for arrays. Like that, so many concepts are there. So NumPy, SciPy. SciPy is used mainly for data interpolation and numerical integration, like algebra, statistics. For that purpose, you can use the SciPy. Here you can install SciPy when you are using the Python IDE. So when you are using the Anaconda Navigator, so no need to explicitly install this SciPy or NumPy or Pandas. Automatically, default you will get, but simply you can import by using the import statements. Okay. Suppose if you want to, you need a data. That data should be standard data to train the model. That data you can get from standard websites like Kaggle. So Kaggle website, suppose there is a Kaggle website. So you can open this Kaggle website, whatever the data you want. So you can search here and you can download the data. Suppose there is an iris data set. Okay. So machine learning with iris data set. So you can download this one. Or simply this is the iris species. You can download it from this Kaggle website. So that the data may be some hundreds of records. You cannot take data on your own. So for any machine learning algorithm to model any machine, so you can take only the standard data. That data you can get from the Kaggle website. Suppose you want to take that iris species, or you want to take some weather conditions in a particular area. In your area also, you can search in this Kaggle website. In Bilai, so you want to take the data set of that weather conditions. You can search in this one. You will get the data set. You can download the data set, and based on that data set, so you can predict whether that rain is occurred today or not occurred. So like that, so you can use this standard data from this Kaggle website. Okay, so like that. So pandas are using for data manipulations and reshaping of the data sorting, aggregation of data, and you can handle the missing data. Suppose whatever the data you have as a training data, in that one, some data may be missed, some fields may be empty. So those such type of fields you need to remove. So that is called data pre-processing. Before before feeding the data to the system, you need to pre-process the data. So how you can pre-process the data? By using this pandas, and you can handle such type of you can identify such type of missing data, and you can predict, or you can remove that empty fields, like that. So these are all our different libraries regarding Python to handle any data science or any machine learning algorithms. Okay, the time is running. Anyway, I want to stop this lecture here. because it is difficult to explain the entire one within an hour. So whatever that time I have given, so in that time I have completed. I think it is only 5 to 10% only. Okay, I completed the lecture.
Thank you very much, sir, for your precious time. Now I would like to invite Manisha Sahu from MSc final year to convey a vote of thanks.
Good afternoon to all. I am Manisha Sahu, student of MSc 4th Sem Computer Science Department, Sri Shankaracharya Mahavidyalaya. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. First and foremost, I thank our special Dr. J. Durga Prasad Rao sir. Stewardship supports vision and commitment. My heartfelt thanks to the head of department of computer science, Mr. Thakur Devraj Singh sir, valuable contribution, guidance, and encouragement, and all our efforts. I thank all the invite is present here expecting the invitation. I thank the faculties of Computer Science Department, Yadav ma'am, Mrs. Kavita Kushwaha ma'am, Miss Jaslin Kaur ma'am. I thank students of Sri Shankaracharya Mahavidyalaya for your cooperation in making this function a resounding success. I thank all the students who have joined this webinar. Once again, I thank you all for your attention. Thank you.
Thank you, Srinivas Rao, sir. Thank you.
Thank you all.
Vast
Thank you.
topic, sir, and within a one lecture it is not completed. But within a time you have completed some important topics, sir. Thank you for very much, sir. We will associate with in future also, sir. Thank you very much.
So thank you for giving me this opportunity in this training program. Thank you, sir. Thank you all. Thank you. Thanks to the management. Thanks to the faculty and students also.
Thank you very much.
Thank you, sir. Thank you.
Quiz link and feedback link will be shared on groups, so check it out.
Sir, can we leave now?
Yes, ma'am.